Denisovans are the first ancient hominin species to be identified only by genes, not by fossil classification. Despite being placed in the genus Homo, they have not yet been given a species classification because no physical description exists. They are named after the Denisova cave in Russia, where the first fossils were found. The age range given for the species is approximately 500,000 to 30,000 years ago, based on dating the few fossils that exist and findings from genetic studies and sediment analysis. Sediment analysis in Denisova Cave suggests that Denisovans lived at the site between 300,000 and 50,000 years ago. Denisovan fossils have only been found in layer 11, but they are so fragmentary that they cannot be dated. Radiocarbon dates of animal bones in the same layer are 50,000 years old, but the youngest part of layer 11 is 16,000 to 30,000 years old. More work is needed to determine the exact dates of this layer and the Denisovan remains in the microstratigraphy. Genes suggest that Denisovans are cousins to Neanderthals and that the two diverged around 400,000 to 500,000 years ago. Research on Denisovan DNA in modern Papua New Guineans suggests that the two populations interbred around 46,000 years ago. It has also been suggested that another interbreeding event occurred around 30,000 years ago and possibly as recently as 15,000 years ago. The evidence for the latter date is disputed, but it seems likely that Denisovans were still present at least 30,000 years ago. To date, fossil specimens have only been recovered from Denisova Cave, a remote site in the Altai Mountains in Siberia, Russia, and the Baishia Karst Cave on the Tibetan Plateau in China. However, genetic studies suggest that the Denisovan homeland once extended from the Altai to Eastern Asia. Denisovans contributed to the genes of today's Melanesians and indigenous Australians, so they may have been present in a region where they could have interacted with the ancestors of these people as they migrated across southern Asia. What does the name mean? Denisovans are placed in the genus Homo, but still have no universally accepted taxonomic name. They are named after Denisova Cave, Siberia, Russia, where the fossils were first found and identified. Denisova Cave was, at various times, home to three species of humans, Denisovans, Neanderthals, Homo neanderthalensis, and modern humans, Homo sapiens. A Neanderthal foot bone, identified by DNA, was found in the cave in 2010 in layer 11.4 of the Eastern Gallery and was contemporary with the Denisovan finger bone. Neanderthals also left Mysterian stone tips and scrapers in the cave and area, which mostly date to about 40,000 years ago. The cave also contained sophisticated stone tools and bone artifacts that may belong to Homo sapiens. The exact dates of the layers in which the artifacts and fossils were found are problematic, and it is most likely that the occupation was sequential. Excavations at Denisova Cave have been going on since the 1970s. But the recent discoveries of human remains made headlines around the world. A small finger bone, Denisova III, was recovered from layer 11 in 2008. Since it was well preserved with a suitable date range between 50,000 and 30,000 years old, it was sent for DNA analysis. The results of mtDNA and nuclear DNA sequencing were published in 2010. The bone belonged to a female of an unknown type of archaic human. Despite being closely related to Neanderthals and modern humans, she was distinct enough to merit classification as a new species. Interestingly, the bone also contained a small amount of Neanderthal DNA, indicating that the two groups had mixed before. Since the growth plate on her finger bone was not fused, the girl was probably between 5 and 7 years old when she died. Other specimens recovered from Denisova Cave, identified through their DNA, are Denisova II, a molar found in 1984, estimated to be 122,700 to 194,000 years old. Denisova IV, a molar found in 2000. Denisova VIII, a molar found in 2010. Denisova XI, a long bone fragment found in 2014, believed to be from a hybrid species. Denisova XIII, a parietal bone fragment from the back of the skull found in 2016 and announced in 2019 after mtDNA analysis. A Denisovan fossil recovered from a different site was announced in May 2019. A jaw was found in 1980 by a Buddhist monk while exploring the Baixia Karst cave in Gansu, China, which was taken out of storage and reanalyzed. It was identified using protein analysis, as DNA could not be extracted. U-series dating of rock material associated with the lower part of the jaw dates it to at least 160,000 years old. The elevation of this new Denisovans home, 3,280 meters above sea level on the Tibetan Plateau, while surprising, explains the Denisovan genetic contribution to modern Tibetans. See below. All specimens identified as Denisovan were identified based on protein or DNA analysis. No specimen has yet been described as Denisovan based on anatomical features. However, it is very likely that some unclassified hominin fossils from Asia, such as Penghu 1, Dali, and Suchong 1 and 2, skull fragments discovered in Lingjing in 2017, are Denisovans. However, they are not suitable for DNA testing, so their relationship to Denisovan fossils is unknown. Evidence suggests that Neanderthals, Denisovans, and modern humans all descended from or share a common ancestor with Homo heidelbergensis. DNA evidence suggests that this common ancestor lived about 600,000 to 750,000 years ago. Therefore, it seems likely that around this time, a group of ancestors of H. heidelbergensis migrated from Africa and then split up shortly after. One branch moved northwest across West Asia and Europe and became Neanderthals. Another branch moved east and became Denisovans. Those who stayed in Africa evolved into modern humans. DNA evidence also makes it clear that these three closely related species later met and interbred, and each species provided genetic material to the others. For example, living Europeans and Asians inherited about 1 to 4% of their DNA from Neanderthals, and Tibetans, Melanesians, and Australian Aborigines carry about 3 to 5% Denisovan DNA. This is explained by the interbreeding of East Eurasian Denisovans with modern human ancestors of these populations as they migrated towards Australian and PNG. According to a detailed analysis of DNA from people living in Indonesia and Papua New Guinea published in 2019, our species, Homo sapiens, may have been interbreeding with Denisovans as early as 15,000 to 30,000 years ago. Studies suggest that Denisovan DNA in modern humans may be heritable. In 2014, researchers found that ethnic Sherpas inherited a super athlete, gene variant EPAS1 from Denisovans that helps them breathe easier at high altitudes. One of the biggest discoveries relating to interbreeding between human species was the discovery of a first-generation Neanderthal Denisovan hybrid, or a person whose parents belonged to two different species of humans. Denisovan 11 is a long bone fragment fossil found in Denisova Cave in 2012. It was stored in a collection of over 2,000 unidentified bone fragments until 2016, when protein analysis was carried out on several of the fragments to see if they were human or animal. Denisova 11 turned out to be human and was then sent for more detailed analysis. The fossil turned out to be that of a girl, now nicknamed Denny, who was at least 13 years old and lived around 90,000 years ago. Her DNA analysis was published in 2018 to much excitement. Denny was a first-generation hybrid with a Denisovan father and a Neanderthal mother. The genetic study was led by Svante Pabo and Vivian Sloan of the Max Planck Institute for Evolutionary Anthropology in Germany. Since very few Denisovan fossils have been found, most of what we know about extinct humans comes from their DNA. The species has not yet been described based on anatomical features, but the following traits are evident. Large and lack the specialized features found in Neanderthal teeth. They have several unusual cusps and do not resemble modern human molars. Share no derived morphological features with Neanderthals or modern humans, further indicating that Denisovans have a different evolutionary history from Neanderthals and modern humans. Jaw. The jaw of Shaha in Tibet is robust and shorter than that of Neanderthals. Culture. While thousands of artifacts have been recovered from Denisova Cave, none of them have been linked to Denisovans so far. This makes it difficult to form a detailed picture of the cultural characteristics specific to Denisovans. However, it can be assumed that they were relatively advanced in terms of intelligence and lived a lifestyle similar to other humans at this time. But for a while, they were kings of the north, their spears slaying the mightiest beasts, their fires burning bright against the darkness. Please watch the channel's other videos to learn more about our shared human history. Thank you, and take care.